we have Dr. Charlie Sanchez, and then he'll be joined by Dr. Andy French from the USDA. Charlie's first going to talk about a project we did on heavy metals. We collaborated on a rapid response project with the Center for Produce Safety to look into that, and then he and Andy will roll into a large irrigation and salinity management project that's going on right now. And I want to recognize, I see Mark Smith in the audience. Mark's been a big part of driving that and making that happen. So it's another really exciting project that we're doing. And like Frank mentioned, the other neat thing to see is how all these are starting to come together and impact each other and be able to build off of each other. So with that, I think I'll turn it over to Charlie.
So we began to collect more data, and we began to seek mitigation strategies. And one thing that became obvious to consider, at least in the short term, was soil testing. And we had some funding. We were proceeding to do this. In the meantime, YCEDA, in cooperation with the Center for Produce Safety, asked what they could do to hasten the database, the development of the database, and come up with some strategies quicker. So this is the specific area I've been asked to talk about today. Little bit of listing of the objectives. The first of all, we were going to collect high-resolution soil samples. Now, this wasn't a trivial issue because there's lots of variation in the field. To what extent does that variation confound taking a representative sample is a valid question. In fact, for phosphorus, it's very hard to get a composite sample because the CVs exceed 50% and the data is often skewed. It's not even normally distributed. So it's hard to mathematically make the correction for a measure of central tendency. They wanted to double the database we were collecting, and we did that. And of course, they wanted to explore zinc fertilization as a mitigation strategy. The California Leafy Greens Marketing Agreement recommend this. There was some interest in seeing if this was a viable strategy here. California's committed to total cadmium. Essentially, you take a soil, you digest it in acid, and you measure total cadmium. I was more inclined towards a bioavailable cadmium. Now, typically, there's no relationship to being total and plant available. Cadmium's an exception. DPTA is almost exactly half total. Here or California, anywhere, we're getting this kind of data. So you can use one or the other. You just either divide or multiply by 2. Now, we evaluated a number of extractants, and I found that the DPTA bioavailable cadmium was as good as any. But it's not sufficiently good to be a standalone predictive tool. This shows some data we collected. This was a fairly large database, and I did some probability analysis, and I only used the European Union threshold of 200 parts per billion, or 0.2 parts per million is a threshold. And you can see if we wanted to stay between the probability of staying between 200 and the ranges we detect in the soil isn't very good. So if we get a range of 0.12 to 0.15, we only have a 50% chance of being below the European Union threshold of 200 parts per billion. This is not acceptable predictability. So we quickly came to the conclusion that there were other factors in the soil that affected cadmium uptake by spinach. And we started out by looking at the resolution of soil. So we went into a lot of spinach production units. Spinach production units are smaller than produce or broccoli. They're usually 10 acres or 5 acres. They're a planting date and a variety, and they're made to fill a specific order by a shipper. So we went into various spinach production units and took very high resolution GPS reference soil samples. And we looked at the trends. Interestingly and fortuitously, the data is normally distributed, and it's not extremely variable. So you can take a composite sample from a spinach production unit. You can see the means and the medians are very close. I have here zinc, cadmium, lead. Lead's another story for another time, but I went in and collected it anyway. And this quickly told us we can take a representative soil sample. Moving along, this is just some images of some of the data. We took GPS referenced soil samples, and then we just simply plotted them using some geostatistical plotting program, and you can see the variation. The top two would be, we have field 1, field 2, we have several, but I'm just showing 2 here, would be zinc variation in the soil. The second set of figures would be cadmium variation in the soil by bioavailable DPTA. Now, we began to look at other soil properties that might impact cadmium absorption. And we had 2 things in mind. One was to find some that did have an impact, and 2 is to try to dovetail it into existing soil test protocols so that this wouldn't be an expensive endeavor to shippers or producers. So we tried to use soil tests that would be normally done anyway. So the DPTA is always done for micronutrient recommendations. So we have that for zinc and cadmium. pH is always measured by soil testing labs routinely. Instead of soil texture, which is an expensive analysis, we looked at saturation percentage, which is highly correlated to soil texture. You can predict soil texture from saturation percentage. Soil chloride affects cadmium uptake, but we looked at simple measurements of electrical conductance in lieu of chloride, in addition to chloride, to see if this could work. Let me back up. And we looked at soil test phosphorus. Interestingly, we have correlations. Now, this is the relationship between spinach uptake and the soil test level. Cadmium, we get a positive correlation, but we get a negative correlation to zinc. We get a negative correlation to phosphorus. And we get a positive correlation to salinity or electrical conductance. So clearly, these are parameters we got to integrate into any predictive soil test algorithm. So where are we going now? A little bit about zinc fertilization. Here's 2 studies. We did a lot. It doesn't work. Don't do it. Don't waste your money. That's the short story. Here's zinc. They're recommending high rates. You can apply high rates, and you can see there's virtually cadmium. Here's plotted parts per billion, zinc parts per million. You can see there's really no meaningful differences in cadmium accumulation as a result of zinc fertilization. Now, this seems contradictory. I just told you it's inversely related to zinc soil test in the soil, but yet we can impact it by zinc fertilization. That's the way it works out. The pools we're adding are insignificant to the pools that already exist in the soil. So it is negatively correlated to zinc, bioavailable zinc, but you can impact it by zinc fertilization. Interestingly, though, the good news is about half our spinach sites will respond positively in yield to a low level of zinc. So about half the spinach fields I looked at, you get a positive yield response to about 25 units of zinc. So there is a zinc deficiency, but as a tool to mitigate cadmium, no way, no how, don't do it. So to summarize where we are, what we learned, first of all, the high resolution soil sampling shows that there's generally good opportunities for taking a representative soil test. Variation's low, the data is normally distributed, you can get a good sample. Data show that in addition to soil test cadmium, soil test zinc, soil test phosphorus, soil salinity, were all correlated to spinach cadmium concentrations. These need to be worked into our predictive algorithm. These data show that high applications of fertilized zinc is not an economically viable mitigation strategy. The final note is, though, where are we? The European Union has 200. We're nowhere near that. California has worked in some voluntary compliance into their marketing agreement, and they kind of reference 1 part per million soil test as a level of concern, although it's not strictly enforced. In the desert, we're nowhere near 1 part per million. We do not have a soil that tests 1 part per million. So my position at this point, unless the tolerances change, we should not burden ourselves with we should not have to burden ourselves with taking soil samples or tissue samples, because we're well below the voluntary criteria that California's implemented and their shippers are enforcing on all of us. The last thing I want to mention is where we're going. Essentially, we're doubling our database again. I want over 500,000 paired, 500 paired soil samples, spinach samples. Then we'll do some stepwise regression and compose our soil test predictive algorithm. Now, what use will that have? Should we choose to import to the European Union, where 200 is enforced, or should Canada adapt European Union criteria, or Mexico? We have a tool to pick fields that we can come in below that. About 50% of our spinach is above the European Union threshold, but about 50% is below it. And using these soil tests, we can predict fields where we will come in below it. That's all I have to say on this issue. If I have any time, I'll answer any questions.